Let's talk about finding quadratic sequences. So when we find our quadratic sequences, we should end up with an square plus bn plus c, where a, b, and c are just numbers. A and b are coefficients of n, and c is a constant on the end, but they're all numbers. Alright, let's start by looking at a quick sequence. Alright, here's a sequence. Doesn't look like your regular sequence, but I can tell you it's a quadratic sequence. So if we are able to find the quadratic expression that made this sequence, then our life will be great. Now, let me start by putting a few bits and pieces in, like for example n. n is the term, or well, each term. So for example, 7 is the first term, 16 is the second term, this is the third term, and the fourth term, and the fifth and the sixth term here. Now, before we can find the sequence, let's define one main thing. This a that we've got here, a is actually equal to our second difference divided by 2. Alright, so bear this in mind. It's going to come up into play in just a minute or two. Alright, let's go now and start sorting out how we're going to find the nth term for this quadratic sequence, or the formula that makes this sequence work. Well, the first thing that we need to do is find the difference of all the numbers, or basically how the sequence is going up. So we're going to find the difference here. So basically from 7 to 16 it went up, that's 9, and that's 13, and to jump there it's going to be 17, and you can guess what's happening here because you can clearly see a pattern now, and then that's 25. But that's the first difference. Now I'm going to find the second difference. So up here I've got a little sequence going on as well, as I was literally subtracting these numbers. So I'm going to find now the difference of the second number. So this is going to be, so maybe I should label this here as my first difference. This is my first difference here. Now I'm going to find the second difference. So you can clearly see that this is going up in 4s. So basically if you add 4 to the last number, you get the next number. This is my second difference that I was talking about just now. So that tells me straight away that A is equal to 4 divided by 2, which is equal to 2. So now that I know that, I can now go to my equation, my expression from up there, and say that it is actually 2n squared plus bn plus c. Alright, now that solves, it solves a third of my problem. I've still got to go and find what b is and what c is. Well, that's pretty easy. Because I know this is going to look like a quadratic expression, all I need to find out is what actually happens before we got to 7. What happens there? What happens there when n is 0? Because if I know what that is, then that tells me what my c is. Well, okay, that's fine. Let me make a little bit of space here. That's pretty much easy to sort out. Well, if we look at it very carefully, you're going to notice that on top here, my second difference is 4. So what is the number that comes before 9? So if I take 4 away from 9, I'm going to have 5. It means that taking 5 away from 7 will give me 2. And the minute I got that, this is the first number that comes before I actually get to 7. And that tells me now that my c here is actually equal to 2. So I'm going to just rub that out now, and I'm going to put 2 there. And that basically means now I just need to find b. Well, b is easy to find. I can use any number I want. Look at this very carefully here. When n is equal to 1, the answer is supposed to equal to 7. I'm going to use that to my advantage like this. So I'm going to say n is equal to 1, and that implies if I substitute 1 in this expression up here, I can easily put that to 7 and then find b. So here we go. 2 times 1 square, remember n is 1, plus b times 1 plus 2, and just now I just said it should equal to 7. So I'm going to use that to my advantage now. Well, let's solve this for b. Well, 1 square is 1 times 2 is 2 plus b times 1 is b plus 2 equals 7, which means that b is equal to 7, take away both of those 2's, and b is going to be equal to 3, because 7 take away 4 is 3. So therefore my nth term is actually 2n squared plus 3n plus 2. And I am now done. If you want to prove that it works, all you've got to do is substitute another value for n and see if you get the same answer. So I'm going to pick a random one. So I'm going to say when n is equal to, I don't know, 4. So if n is equal to 4, my answer should be 46. Well, let's try it and see. N is equal to 4 here, and that implies 2 times 4 square plus 3 times 4 plus 2. Let's see if we're going to get 46. That's going to now equal to, well, 4 square is 16, and 16 times 2 is 32, plus 4 times 3 is 12, plus that 2 on the end there. And if you add that up, you're going to find out that 32 plus 12 is going to be 44. And then you add the 2 and you get 46. So that proves that this is the nth term for that sequence. Alright, now that I've gone through the explanation, I'll do another one, and this time I'll explain a lot less and work a lot more. Alright, here's my second sequence, and that means that this is my first term, that's my second term, that's my third, fourth, fifth, and sixth terms. So the first thing I'm going to do is find the difference between these numbers. So those are my first lot of differences there. You can pause the video and double check for yourself if you like. Now I'm going to find my second differences, well, which should be my common difference. I'm going to find my second difference. Right, this is clear that my second difference is going to be 6. And so since my equation or my nth term is an squared plus bn plus c, that basically already tells me that a is going to equal to 6 divided by 2, which is my second difference, which is equal to 3. Now that I've got a, I can go ahead now and find c. So in other words, I need to hop back another 6 here. Hopping back another 6, taking 6 away from 7 gives me 1 there. Hopping back another 1 means that that 5 would become 4 here. So therefore, we're practically looking at C being equal to 4, which is the number that comes before the first term. Now that we've got C, we can put them into the equation and go and find anything we want. I tend to like to use the easiest one, so I will start with when n is equal to 1, and I already know that when n is equal to 1, my answer should be 5. So I'm going to use that to my advantage. Now remember a is 3, so 3 n squared plus bn plus 4, and now that we're going to use n is equal to 1, we're going to just substitute every n for 1. So 3 1 square plus b times 1 plus 4, and we already know from the sequence that that should be equal to 5. So now all we got to do is just solve this. 1 square is 1 times 3 is 3, b times 1 is b, plus 4 is equal to 5. Basically that means that b is equal to 5 take away 4 take away 3, which is going to give us 5 take away 7, which is minus 2. And that means now that our nth term is 3n squared minus 2n plus 4. And this is now done. If you would like to make sure that you are happy with that, I suggest you go back to the sequence up here, take a good look at it, probably try when n is equal to 5 or something, and see if you get 69. So I'm just going to write it here for you in case you want to try it. Okay, so I'm going to write down for you that n is equal to 5. You can substitute the 5 into your equation and see if you get, or your expression I should say, and see if you get 69 as your answer. I guarantee you, you would. This is how you find the nth term of a quadratic sequence. If you want, you can, there are other methods that you can use, but this is probably one of the easiest. If you have an easier one than this, please do make a suggestion. We can definitely have a look at that. Alright, fantastic. Thanks. Have fun with this and find the nth term of some quadratic sequences.